Welcome, everyone, to the latest episode of Scrubbing the Skies, the webinar series of the Institute for Responsible Carbon Removal. As always, I'm your host, Will Burns, and I serve as co-director of the Institute. One of the major themes at the Carbon Unbound conference in New York this week has been the question of scaling of carbon removal and ensuring that there is adequate demand for carbon dioxide removal approaches to ensure that we can achieve the prodigious amounts of CO2 removal that we may need by mid-century, which many estimates indicate could be as much as 10 gigatons of CO2 per year, and perhaps even as much as 20 gigatons per year by the end of the century. But the problem that we face is that there is very little demand at this point and very few actors. Indeed, Microsoft is responsible for 65% of all carbon dioxide removal in voluntary carbon markets at this point, and then there's a smattering of other companies. Moreover, while Microsoft is engaged in modest amounts of carbon removal purchases, recent analyses indicate that its Scope 3 emissions rose 30.9% last year alone, probably putting a lie to any assertions that it will go net negative by 2030. So the question becomes, how do we ensure that those responsible for carbon dioxide emissions are truly responsible for having those emissions removed? And how do we do it in a time frame that's pertinent to meet the objectives of the Paris Agreement? And our speaker today is the author of a new interesting study that provides one potential way forward. The study in the journal Energy Research and Social Science is entitled Finance for Future: Enforcing a CO2 Emitter Liability Using Atmospheric CO2 Removal Deposits to Finance Future Negative Emissions. And we have the lead author of that paper, Professor Anders Lingfeldt, who is at Chalmers University of Technology in Gothenburg, Sweden. Welcome, Anders. And we look forward to your participation today. So, as usual, we'll use the following format. We'll have an initial intervention by Professor Lingfeldt to explain the findings of this study and the architecture of the proposal of the authors. We'll then proceed to a few questions that I'll proffer to seed the conversation, and then we will move to audience questions. So in that context, one of the things I encourage you to do is to start populating the chat box, so I have some sense of how long we should accord for those questions at the end. And with that, I will turn it over to Professor Lingfeldt.
Thank you. Oh, can you see my screen now?
Not yet.
Not yet. It says I'm screen sharing.
Yeah, I'm able to see it, Will, if you are.
Okay, it just may be that I'm not seeing it. Okay.
Okay, so I'm going to talk about sustainable financing of negative emissions with a CO2 emitter liability. And my co-authors are Mattias Fridahl at Linköping University in Sweden and Stuart Hasseldine, who is in Edinburgh. The global carbon budget for the 1.5-degree target is likely spent around 2029. So to meet this target, all emissions all CO2 emissions made after 2029 need to be removed from the atmosphere. So this is illustrated by the diagram to the right. So you can see all this CO2 that is emitted after 2030 needs to be removed with gigantic negative emissions. And this leaves our children with a climate debt to remove perhaps 400 or perhaps even 800 gigatons of CO2, which could be up to 100 tons per capita, and at the cost of more than 100 euros or dollars per ton. This would be quite a substantial amount of money per capita globally that would be needed to finance this. And so far, I haven't seen any realistic mechanism for financing of these future negative emissions. It's part of all the models for how we are going to meet the climate targets, but the mechanisms for financing this are not part of these models. So who will take the responsibility to remove all these negative emissions? How can it be shared between countries? Will the rich? I mean, if we assume that the poor countries will not take responsibility for their emissions after 2030, this will put an extra burden on the rich countries, which is reasonable because the rich countries created the problem with their long historical emissions. But it seems that the rich countries really don't have no intention of taking a responsibility for removing their historical emissions, and probably not even take the responsibility of their emissions after 2030 either. And we cannot expect the poor countries to take this responsibility. They have no moral obligation. They will have no interest to clean up after for what the rich countries emitted to the atmosphere, and they will have little money for doing this. And the oil countries will not save us in this, I believe, and not China either. They will claim that they have only a few decades of emissions. And Russia will not be helpful either, I assume. This is difficult. So how would it be possible to find a model to share this? How to share these costs? And if you go to the individual nations, who is going to pay? The taxpayers. Which Ministry of Finance will give priority to negative emissions? I mean, they have a lot of priorities: education, law and justice, social security, defense, healthcare. They normally have a big deficits also in their budgets. So it's hard to see that negative emissions will be given a high priority. So I doubt putting the burden on the taxpayers will not be a sustainable solution to pay for these large negative emissions. So this suggests that we will leave our children and grandchildren with a problem that is insoluble. So, but here we propose the solution of a CO2 recovery liability, which makes emitters responsible for removing their emissions from the atmosphere. And as you understood from the previous diagram, there is there will need to be a significant delay in time from the time that the emissions are made and when the emissions will be possible to remove from the atmosphere. So we need to have a solution which can handle this time delay. But the CO2 recovery liability would be simple, reasonable, comprehensible, fair, rational, sustainable. And I think that should facilitate acceptance. And it would provide a good incentive for not emitting CO2. So here we come back to the challenge. So the idea is that those who emit CO2 after 2030, or perhaps even before that in rich countries, will pay for the future negative emissions. But then comes the question, how can we save this money for 10, 20, 30, 50, 60 years without anyone stealing the money? I mean, if we would build public funds from CO2 taxes, we can guess that these would be appropriated by governments in financial need. So that is probably not sustainable. So therefore, we produce that this liability is operationalized by removal deposits. So the idea is that the emitter has to pay a deposit fee corresponding to the cost of negative emissions. This fee is these fees are put into funds, and the returns raise the value of the deposits, which will raise the incentive for making negative emissions year by year with the returns. And these deposit deeds would then be possible to trade. So not all emitters would be happy to own these deposit deeds. Many would probably sell them to companies that would specialize in buying negative emissions. So the owner of these deposit deeds can buy negative emissions, and when presenting certified negative emissions, they can be refunded, including returns with these deposit fees. So this is the idea. And the owners of deposits will be motivated to make long-term contracts with operators of negative emission plants, which will solve investment and financing of these plants. And so this will secure investment in negative emission technologies and create a market that promotes technology development and reduces costs. So we come to the cost. We have a company in Norway that says we can do negative emissions, or we can do CCS. We can capture CO2 at the cost of 150, maximum 150 euro per ton, if there is good conditions, which includes capture, transportation, and final storage. So all included. So I think this is a reasonable number to start from. Then we can look at the global carbon dioxide intensity, which is basically the global emissions divided by the global GDP. So you see that the carbon dioxide intensity has the unit kilogram of CO2 per euro, whereas the likely cost of negative emissions has the reversed unit, euro per kilogram of CO2. So if we multiply these two numbers, we get the number 0.03, which is a dimensionless number. But what it means is that a tax or a cost of 0.15 euro per kilogram corresponds to 3% of the global economy. That's what it means. But in most cases, for instance, the EU ETS system has halved the European emissions almost at prices which have been typically 0.005 euro per kilogram, a fraction of this. It has been, for a short time last year, it was up to 0.1 euro per kilogram, and now it's 0.05 euro per kilogram, 50 euro per ton. So obviously, having such a cost of emissions would trigger a large number of reductions. And this would mean, since this is cheaper, this would mean that the actual cost for the society of introducing this fee would be well below 3% of the GDP globally. It would be more in some countries and less in some countries. Typically more in oil nations, and typically less in countries like Sweden. No fossil fuels. We know fossil fuels exist in Sweden. We import fossil fuels. So is this a lot? I would say it's obviously less than the 1 year of growth in the economy. And to be honest, would we even notice if we lost 1 year of growth in the economy? I'm not sure. But of course, this cost will trigger significant cost on certain activities like aviation, like petrol, electricity. So, but the overall cost would not be so large. So then we have the problem that the rich countries also need to consider their historical emissions. So one solution to this is overcompensation, which means that we could gradually increase the liability, so that, for instance, an emitter would need to buy deposits for the removal of more than 1 ton of CO2 for every ton emitted. For instance, 1.5 ton, 2 tons, so on. And this could be increased gradually with time. And this could be used for reaching tougher climate goals. It could be used in case of failure to introduce ACORDs in time. It could be used for rich countries taking a greater share of negative emissions in accordance with their historical emissions and greater guilt of the situation. It would also give a higher price, which will promote lowering of fossil fuel emissions, fossil CO2 emissions. And it could also be introduced perhaps selectively for negative emission technologies that are less safe, like nature-based forestry, afforestation and reforestation is a lot less safe than, for instance, geological storage. This could motivate an overcompensation. So to conclude this, the emitter is obliged to buy deposit deeds corresponding to his emissions of CO2 to secure the future removal of these emissions. And trading in these deposit deeds will create markets that enable long-term investment and technology development. The deposit deeds have owners which should protect the money from being used for other purposes. The revenue increases the value of the deposit deeds and raises the incentive to achieve negative emissions. And the deposit fee will also drive emission reductions because it will make it more expensive to emit CO2. And the deposit system can be gradually tightened through overcompensation, which can give further emission reductions and help the rich countries to pay off their historical debts, carbon debts. I would say the system is simple, it's fair, it's rational, and it puts the cost on whoever is causing the problem. And therefore it should gain acceptance. The deposit fee can and should be combined with other instruments that ensure rapid reductions in emissions. We need to reduce the emissions rapidly. Otherwise, there is a risk that the negative emission potential available is exceeded. And I would say that the proposal can be seen as a way of reaching zero emissions immediately, even if there is a delay in the removal of carbon dioxide. So in this way, we could, in practice, reach zero emissions very quickly, and in that way, get the real opportunity to meet the 1.5 degree target. And the socioeconomic cost is reasonable. We're talking about a few percent of the global GDP. And finally, it would mean that we don't leave behind a huge carbon debt and an insoluble problem to our grandchildren. So this is a quick summary of the idea. And to the left, we have an opinion piece that was published in the second biggest newspaper in Sweden. We believe an excellent translation of this opinion piece to English. And if you would have any idea on English-speaking papers or places where this could be published, I would thankfully take any advice on this. So thank you.
All right. Thank you so much for that, Anders. So let's just work through a few initial questions, and then I'll move to audience questions. At the outset of your piece, you referred to an incentive gap in terms of pricing negative emissions, indicating that it's more difficult than pricing emissions. So can you explain why that's the case?
But pricing emissions is, I mean, if you're a government and you want to have a price on CO2 on the emitters, you can, for instance, have a tax, and that will give you a lot of money. And you can give this money back to, I mean, to the public, and they will be happy because they will get the money back. And so it can be very positive. It can help you with budget deficits, but it can give you an income. But negative emission is the opposite. Someone has to pay for this because no one will do negative emissions just for fun. There are significant costs. I mean, I'm saying it's not extremely expensive. It's doable, but there are significant costs and someone will have to pay for this. And this is inherently much more difficult than putting incentives to emitters in terms of costs.
Okay. So let's talk a bit about that. Sometimes I worry when I see.
Sorry, I don't hear anything now.
Can you hear me now? Can you hear me now, Anders?
Should I? I would try to leave and come back.
Okay. Can you hear me now? Can you hear me now?
Yeah, apologize for the technical difficulties here.
So now I can hear.
Okay, great. Okay, so let's follow up in terms of some of the cost issues, okay? And sometimes I'm a little skeptical when I hear an argument, for example, that something's only going to cost 2 to 3% of the GDP, right? Because from a practical standpoint, if your industry, right, of course, it's going to cost a lot more, right? And ultimately, you're going to try to spread those costs out, pass them on to consumers, and so forth. But for you, as industry, it's a very large cost, right? And so would it not be the case that that might render this kind of proposal unviable, right? Either because industry ultimately says no and effectively lobbies governments, especially in places like the United States, never to implement a proposal like this, or when industry starts passing on the cost to consumers, which invariably they will, and raises the price of products, there'll be a backlash, right, against these proposals. What do you think about the political viability of doing this? And one of the things I'd point to is, it was my understanding the United Kingdom was thinking about something like this a couple of years ago and ultimately scuppered it, I think, primarily in terms of political concerns. What do you think?
Well, I mean to solve the problem, we need to have a price on CO2. I mean, it's inevitable, and the EU ETS system is nearing the price we need. Do you hear this echo? No.
No,
It's only me. I hear an echo, but never mind. I'll try to. So I think the costs will, at least in Europe, they will come anyway, and the industry is prepared for this. I mean, they're preparing. The cement industry is preparing for CO2 capture. It's their only way out of the CO2. When the EU ETS system will get less and less CO2. So they will have to do it. and they will have to pay this cost anyway. And the same goes for the steel industry. I mean, cement will be twice as big, but the building will only be 1% more expensive. And I mean, same goes for steel. It will be 30% more expensive, but the car will be 1% more expensive. So when it's trickling down to the consumers, the cost will not be so visible.
Do you think it's viable in a place like the United States, for example, right? The largest industrial emitter, where we haven't been able to pass any kind of climate legislation to date, at least at the national level.
Yeah, I agree. It looks a bit bad in the US. I can understand, but we should also take I think we need to think of the example. I mean, assume we have a lot of grown-ups standing on a beach with children drowning in shallow water, and no one does anything. But if someone steps up, I don't care if my feet get wet, I will go and save these kids, and he rushes out, then it will be very difficult for the other ones to just stand there and look.
Okay, I hope that would be the case.
We don't know.
Yeah, we don't
We have
know.
to be optimistic.
Yeah.
You can never give up.
If you're ultimately imposing perhaps even more stringent obligations, right, to overcompensate, right, and to ultimately pick up historic legacy emissions in developed countries, do you think there's a major threat of carbon leakage as a consequence of industry moving operations to countries that might not embrace it, this obligation, and creating both a race to the bottom and ultimately commensurate levels of emissions because they would move to these kind of regimes?
Well, this problem has been discussed a lot in Europe, and I think we have a solution we have a sort of CO2 border around the European Union. So you can't dump high CO2 products to Europe and to compete with European industry by emitting a lot of CO2 in other countries.
So you'd contemplate that there'd probably be a carbon border adjustment, not only in terms of emissions, but also in terms of negative emissions ultimately?
Or I haven't thought of negative emissions, but we certainly have it for the positive emissions.
Yeah, well,
I mean, the cost would be on the fossil CO2. So the same solution would apply. I mean, the same solution which secures the EU ETS system against CO2 leakage would be applicable for this. So I don't see the difference really.
Okay. Can you elaborate a bit why you don't think this accord system could be introduced directly into the EU ETS? Because I know there's been some discussion, right, of how to incorporate CDR into the EU ETS, and you make it clear in the paper that you don't believe that direct incorporation would be judicious. Can you explain that a bit?
Well, it depends on how it would be introduced, but we have to recognize the time delay needed. I mean, if fossil emissions would have to be compensated when they are made, it wouldn't work, because we don't. I mean, we have the big emissions first, and then gradually we will increase the negative emissions. So we will need a way of saving the money from from the point in time when the emissions are made and when the negative emissions will be made. And I think the best way to save this money is in the form of deposit deeds.
Are you fairly confident when we look at the landscape of CDR technological options that those options will be available at scale in a time frame that's pertinent for meeting, if not meeting the Paris temperature obligations, but having a reasonable glide path in overshoot, right, back to drawing down below those temperature levels? Do you think we'll have enough of these, at least the durable technological approaches to facilitate that?
Now something didn't work. I tried to share screen, but I'll skip this green sharing. I mean, we have several negative emission technologies available. We have bio, CCS, or BECS. We have afforestation and reforestation, and they are both very significant. And we have other technologies which are not so well known, like enhanced weathering and ocean alkalization. But I think there should be big potential in enhanced weathering. And then we have finally, of course, the very expensive direct air capture. And for at least a fraction of the negative emissions, this would be possible, I guess, in the future. But I expect it will be a lot more expensive. But if we look at bio-CCS, it's always said that you need another India. You need gigantic monocultures of energy crops. But if we look at what we're actually harvesting, I mean, the global fossil emissions are 37 gigatons. And what's captured by plants is 220 gigatons. That's above ground. Totally, it's 450 gigatons. Of this, we extract gross 32 gigatons, not so much less than the fossil emissions. And the net is 22 gigatons. So this is what leaves the forest and leaves so 10 gigaton is left in the forest and on the farmland. So of these 32 gigatons, I know 6 gigatons cannot be used. 3 gigatons is respiration of animals, our animals, and 3 gigatons is respiration of human beings. So food and fodder. But the rest, no one has been able to answer me why we can't use this. I know it's difficult to assess this, but it's there, and it should be the first choice for negative emissions, what we actually already harvest. It creates a number of waste streams, and we should be able to prevent this CO2 from returning to the atmosphere. And it is expected that the harvest will increase very significantly in the coming decades. So there should be a significant potential already in bio-CCS. And then we have forest plantations and other measures also. So I think for me, the problem is not the potential. The problem is getting the CO2 emissions down quickly enough and provide the money for the negative emissions, create the market.
Okay. All right. Let's move to some audience questions. Does Professor Lingfeld have a comment on whether ongoing litigation such as California's or climate Superfund bills such as Vermont's could be adapted to bringing accords into being? You may not have heard about some of this, but Vermont essentially is seeking to pass legislation that would somewhat mirror Superfund requirements of paying for cleanup, though most of the focus is actually on things like adaptation. But it's loosely the same sort of principle. Do you think those kind of bills could be adapted to incorporate the Accords system that you're talking about?
Well, I don't know so much about it, but I think all systems can be tweaked and adapted towards if we know what we want, and if we know that we need to put the cost on the emitters and have a way of creating money for negative emissions. I mean, that's the key. But I think the deposit deeds is a very good idea.
Okay. Next question. Can you discuss further how limits on specific negative emissions could be implemented? For example, cost estimates of DACs are currently much higher than the example of $100 and $150 per ton of CO2. So deposits requiring this type of negative emissions would need to be invested a very long time before they're profitable to redeem, which is undesirable from an environmental perspective. Would it also make sense to use differential deposit fees to address this concern?
Yes, that would make sense, and it would probably I would if I mean we're talking about a time range of 75 years from now. So and if we look at a few decades ahead, we will have these hard to abate emissions. I mean, if in 2050, 2055, and then we could look at having special fees for these, higher fees for these, or perhaps I mean we could set we could force these emissions to go for DACs, direct air capture, if we assume that if we're at that point have really absorbed all the bio-CCS that's there, and then we could put tougher conditions for the emissions at that time.
Okay. Next question. I'm curious to know what sectors Dr. Lingfeld argues that this tax should cover. Major industry, all sectors, agriculture? If so, how does he imagine measuring the emissions from extremely heterogeneous farms?
I've always only considered carbon dioxide, and that's easy to measure and easy to control. I mean, you have the oil companies distributing the oil. You have the power companies burning coal. I mean, you don't burn coal in small scale. It's not. I mean, using fossil fuels is not really something that you can hide. Not like drugs. You can import and use or sell without anyone finding out.
Right.
So
another question related to logistics. Which body will establish this system of charges? Do you envision specific countries introducing it unilaterally or enforcement by an international agency?
I think it would start in some countries or groups of countries. For instance, the EU could start this, and then the other countries could follow the example.
Okay. And you think it's realistic that that a place like the EU would implement something like this unilaterally, given the potential implications for competitiveness?
Absolutely. I mean, it won't be more expensive than the other systems for driving down the CO2 emissions.
Yeah, but we've already seen the UK say no on this, right? And one of the reasons that they cited was cost, right? So they obviously, the UK government, at least the Johnson government, perceived that this would be an additional cost over and above EU ETS obligations, for example. Do you think this will be as easy as you're envisioning here?
I'm not saying it's easy, but we have to solve this problem, and we have
Right.
to
That
work
again,
for solutions.
I'm just trying to figure out, right, politically viable solutions, right? And whether we think that can happen. Um, so another question. Have you discussed this proposal with the fossil fuel companies, for example? You have any sense of their sentiment about this approach?
I don't see that they would be worried. I mean, they wouldn't have a bigger problem with this than with any other incentives for stopping CO2 emissions.
Right. Well, they wouldn't have any, they might not have any incentive to oppose this that's higher than others, but they've traditionally opposed carbon taxes. Certainly in this country, they've opposed cap and trade proposals. Um, by that analysis, doesn't that mean that they're likely to oppose this also? And given the fact that many of those companies are in the United States, right? Isn't that going to be a major political drag on this happening?
Well, I mean, we're going to net zero in Europe in a few decades, and this is, I mean, the system is there. The EU ETS, it will be less and less CO2 emissions with every year. So they will have to go to zero.
But if fossil fuel companies are based in the United States, for example, and ultimately uh, uh, this is tried in the United States, is it likely that they're going to be any more amenable to this than they've been to carbon taxes or cap and trade proposals? I'm just focusing on the largest industrial emitter in the world, right? Which is us.
Yeah, China is the biggest emitter.
Yeah,
And they have
industrial,
they have a cap and trade system.
right? But it's at an extremely modest level, right? Which is kind of indicative of the fact that politically it's difficult to impose high costs that realistically get you there, right? The IPCC says we need, maybe $400 per ton to get to 1.5, right? And and China's is nowhere near that, right? So are they going to be willing to take on these kind of costs either? And if China won't do it and the United States won't do it, is island Europe sufficient to make a real dent? I'm just trying to figure out the politics of this.
Europe is not sufficient, but I mean, if Europe starts and shows the way how to get to zero effectively, I mean, what about Japan, Australia, New Zealand? Canada. I mean, this will put pressure on the US, and things can change.
Okay. All right. Question on BECS, and this is one I had too when we're thinking about BECS leading the way, right? The question is, the NEGM project recently concluded that any expansion of BECS would breach planetary boundaries, even with a large dietary shift. Why are you confident that it can be used safely?
Well, I think if we focus on the waste streams, we're not taking out any more biomass.
Yeah, but did the waste streams get us there? My understanding is especially because you have to leave a large amount of the residues on land for nutrient retention, or you're going to see crop yield declines, which means you're going to have to expand the land you're using for agriculture, which produces greenhouse gas emissions, right? My understanding is that if you're going to get even to about 3 or 4, right, you're going to need large amounts of dedicated energy crops, which is going to displace food crops, right, and raise prices, require huge amounts of fertilizer, right? I'm somewhat sympathetic to NEGM's conclusion that BECS at even 3 is potentially not sustainable, right? So what where are you drawing the conclusions that we're going to be able to rely predominantly on residues and get us to
Well,
some big number?
the big numbers that we're actually extracting. I mean, someone has before they say that it's not possible and that we need these gigantic monocultures. I want someone to explain why we can't use what we're already harvesting.
Well, I think that's what NEGM did. NEGM looked at it estimated what percentage of residues it estimated total residues, crop residues, right? And then it estimated the amount that need to be retained on soils to ensure viability, and then it calculated what you would get from that in terms of driving BECS, and it concluded that it would be pretty modest, and that if we were going to go to 2 or 3 or 4 or 5, we were going to need large amounts of dedicated energy crops. And then that creates all kinds of problems, right? Biodiversity, fertilizer, water, right? There's some estimates that if you go to 3 gigatons, you need as much water as all of the irrigated water we use on Earth currently, right? And obviously, we're not going to do that, right? So if BECS can't get us there, and DAX is very expensive, and enhanced mineral weathering is in a very early stage, and we're not certain how large it'll ever get, and the same with oceans. How are we sure that ultimately down the road we're going to get the amount of sequestration that would drive this system and make it viable?
Yeah, I am optimistic about the potential. I am very pessimistic about the political decisions. That's my view. But I'm not. I don't know. I don't have the perfect answer. I don't know why we can't use these 32 gigatons that we extract. Perhaps NEGM is right, but I'm not convinced.
Okay.
I think we're extracting so much, so there should be a lot there. Perhaps not 10 gigaton, but well.
Okay. All right. This is more of a comment than anything else, but in terms of political buy-in, and I think this is something you agree with, or it's kind of contemplated with the system that you create. It says a phase-in with initial obligations being a fraction of emissions can help overcome political and cost objections. That approach can help buy down the cost of removals. I assume you agree with that?
Yeah.
Okay.
And I think negative emissions can be done at much lower cost. I think we have chemical looping combustion. There is no energy penalty, essentially only for the compression. This process works excellently. We have 4,000 hours of pilot operation at Chalmers.
Okay. Next question. Are there any historical examples other than U.S. big tobacco settlements following litigation in the 90s that offer an idea about a mechanism by which accords could be instantiated?
I don't know. but I mean, we have solved quite a number of very tricky problems, and I mean, countries that are at war can quickly change their economy and efficiently focus on changing their productions quickly to something very different. I mean, you have the examples from the Second World War, UK. I mean, if there is a will, the economy can be changed quite quickly, and to a very much greater extent than what is needed to meet the climate problem.
Last question. Could you argue that this proposal provides a potential revenue stream for emitters like fossil fuel companies, as in if the value of the deed grows in 10 years and the cost of removing CO2 decreases, could an emitting country that buys a deed now and is refunded with their removal later see a profit?
Yeah, definitely. I mean, Sweden could do great profits in this. We could go minus 175%. We have our large green CO2 emitters are almost as big as the total fossil emissions. So we have a large number of chimneys emitting CO2 from soda boilers in the forest industry and combined heat and power plants in district systems fired with waste and biomass.
Okay. All right. Well, that's a perfect place to end. We are at the top of the clock. So I would like to once again thank Professor Lingfeld for his presentation, as well as all of the questions from our audience. Please look out for announcements for our webinars in June, for which there should be 2. And with that, we will say goodbye today. Thank you.
Thank you.